For this example, we will review conditional and iterative statements. So the way to do this is we're going to build that mini calculator that we did when we did an example for conditional programming. We're going to redo the same thing, okay? However, this time the whole program will be controlled by a loop. So for example, we could have a menu, and as long as we want to stay in the calculator or in calculator mode, the application doesn't die off, okay? So we need to control the loop to run that menu over and over as long as we want to do an operation other than exiting. So to give you an example of that, so this is what we call the program control. We could have a menu, so let's go ahead and do an int choice. So the variable choice will be for the menu. Now remember, at this stage, I'm cramming all the code within main. In the future, I'm going to break up a program like this one into many, many functions. So for now, bear with me, everything is going to be crammed right here. So for the menu to display, we at least know we're going to display it once. Okay, so maybe a do while loop is a good idea. So maybe something like this, do, and open curly brace, that's the beginning of the loop, and the end of the loop is really the end of the program. But that will happen equals, or is not equal to, for example, some exit condition. So in your menu, maybe 5 is the way to get out. Well, let's find out. So let's go ahead and do a menu. So the way to display the menu is you could do something like this, cout. And let me do a /t/t. /t is basically gives me a tab, so it's an escape character. Main menu, or you could call it the calculator menu. /n, give me a new line. Okay, so no semicolon here. I'm just going to line up everything that I need here. Just like we did with another video where we built a mini calculator. Same menu, similar to that. So /n, and then we're going to do /t/t. 1 will be addition. We're going to do addition and subtraction for now. We could add more features as we go. /n and /t/t. That would be 2 subtraction. Okay, so /n. These will be your two options for now. You could add multiplication, division, whatever you want. Sine, cosine, right? Factorial. Okay, so /t/t. And we're going to put 5 here. And I'm just leaving 3 and 4 as not valid. You have only 1, 2, and 5. So that just gives me space to put 3 and 4, a couple more operations if I needed to. So there are no rules what value should you pick to exit. Okay, so as long as it's not a number that you've already assigned to a line item in the menu. So /n. Oops. And here we're going to ask the user, a single /t, enter your choice. No /n here. We want the prompt to be right next to it. So cn choice. Now I can show you right now how this loop is going to work. So let's go ahead and save this program and compile it. So this is example 33. So let me just copy the name. And I'm going to paste it right here. We could test it right away to see if the actual menu works. So compile and run. And sure enough, the menu appears. So let me just make this a little bigger. And let's put it at 28. It's pretty good. There you go. So if I pick 1, what's going to happen is I'm back to the operation of the menu displaying. If I pick 2, then I get that. If I pick 3, any number other than 5, then I will get that. If I pick 10, that will be there. If I pick 5, however, that will kick me out of the loop. Okay? So 5 kicked me out. Notice I didn't put a statement to hold the screen or anything like that. That kicked me out. Perfect. Now, wouldn't it be nice that every time you loop, that you clear the screen? Okay, we could do that. We could do it right here. We could do a system. I believe in DOS it's CLS, if I'm not wrong. Well, let's find out. Otherwise, you'll have to write the word clear if it's Unix, Linux based in terms of running the shell command to clear the screen. Well, let's find out. So compile and run. And let's pick 1. Watch what happens. The screen clears and I'm back to the main menu. So unlike the previous version of this code, it kept writing to the console and the cursor kept going down. This time it clears the screen and we start over. 2, same thing. 10, same thing. Much better in terms of stability. 5 will kick me out. Okay? So it's a good place to put a clear screen right there. Okay? So this clears the screen. Okay? That statement. So it's similar to system pause that holds the screen for you. So CLS and pause are DOS or disk operating system commands. They're within the Windows shell, right? So they came actually with DOS. So great. So now that we have this, can we do a switch statement based on addition and subtraction? Yeah, we could do something like this. Switch based on choice. Notice I'm doing this within the body of the loop. And then curly brace, curly brace. Okay? Why? Because I want these operations to happen. Case 1, do something. Right? And I'm just going to put a break here. Right now we're not doing anything. And I'm going to do case 2. And again, do something. Break. I'm going to fill the code for this. But at least I know that these 2 cases are valid cases. Right? So what happens to case 5? Case 5, maybe this is a place to hold the screen. Right? So something like this. System pause. Let's test it out. Before I do that, I need to break and maybe create a default. Remember, what if it's not 1, 2, or 5? That's fine. That means maybe you should print error, invalid choice. All right, well, let's see how this behaves. Okay, we know 1 and 2 are not going to be invalid, even though they're not doing anything yet. The key behind this is that now 1 and 2 and 5 are within the list of valid cases, where 5 specifically holds the screen for you before you get out. And any other value other than 1, 2, 5 should bring up an error message, invalid choice. Well, let's see how that works. So compile and run. And let's put a 10. We know it's an invalid choice. And notice that it went too fast. Let's see here. It went too fast. So invalid choice. So let me just exit. So maybe a system pause here as well. Maybe something like this. System pause. Now, you know what? Since we're going to do system pause every time, why don't we do this? Message here. See out. Goodbye. And this way, I can put the system pause right here. So that way I could reuse system pause. Either you chose any of them. Any of the cases, it will hold the screen at least temporarily. All right, so let's see how that behaves. Okay, everything is in the placement where you strategically place your lines of code. This here will execute after you've evaluated the value of choice, which is perfect. That's exactly what I want right now. Let's see. So compile and run. And let's pick 10 this time. Watch what happens. Invalid choice. Press any key to continue. Excellent. Let's do a 0. Same thing. Invalid choice. Press any key to continue. Now, if I do a 1, it simply is going to say press any key to continue, even though there is nothing. I haven't filled in any instructions for case 1 or case 2. Let's do 2 as well. You can see. Only press any key to continue, which is system pause running below the highlighted area. Now, let's suppose I pick 5. Now, watch this. Goodbye. Press any key to continue, and I'm out. Okay? So the sequence that I picked here is fairly okay. So now, here, I can go ahead and ask for the first number and second number, and then go ahead and add them, right? So something like this. So in that case, you need a couple numbers. So maybe I need double var1, var2, and result, right? So something like this. And then we could ask cout, enter 2 values to add together. Okay, so cin, and I can enter var1 and var2 at the same time with a space between them, and then result equals var1 plus var2. Now I could have added these in a print statement, and then maybe something like this: cout result equals result, and out. Now let's see how this behaves, right? So we're adding 2 numbers, right? And we will display the result here. So this is for the addition. Let's see if it works. So let's compile and run. And let's see here. I have a space here. Remember, these are variable names. You can't have spaces between the letters and the numbers. They're one word. So compile and run. There you go. So let's do addition. It's going to say enter. I should have spelled 2 values. So I'm going to this is where you test your code and look at the output to make sure you didn't have any spelling issues or grammar or things of that nature. So let's say I have 23 space and 7. Let's see what the result is. Result is 30. So it works. So let me exit, fix the code, 2 values. There you go. To add together. Now, we're going to do the same thing for subtraction. So it's going to be very similar. So I'm going to copy all of this and paste it here, except this is going to be to subtract 1 to subtract. And from each other. And here you will have a minus. And let's see how this works. So compile and run again. So let's do addition. 1 space 2, no problem. 3. Press any key to continue. It'll take me back to the main menu. Do 2 or do. So 2 values to subtract from each other. Fine. I want 3 and 1. And the result is 2. So it works. Let's do a 5 now, or let's do a 4. We know 4 doesn't exist. Invalid choice. And let's do a 5. Goodbye. Press any key to continue, and the program ends. So what have we learned from this? Is that you can have a loop right here, a do while loop, that controls the whole application. So this loop here, we're going to call it the application loop for the whole thing, for the whole program. Okay? And notice I chose a do while loop because I want the body of the loop to at least execute once. I want all of this to be assessed at least once, right? Including the system pause. So what's going to be in it? Well, we're going to be clearing the screen. Next, we're going to display a menu. And we're going to ask then a user to enter a choice based on the menu. And then we will evaluate based on the value of choice which of these cases we will execute. Case 1, case 2, case 5, right, for leaving, and any other case that's not in here, like 4, 3, 10, minus 200, will become a default, which will lead to a printout saying invalid choice. And then we strategically placed system pause right after the switch statement, so that way every time we went through any of these cases, including default, it ran this one before the loop got assessed again. So even on your way out, let's say you picked 5, system pause will be executed, since if it is 5, then the case will be this. You will break from the case, which forces you to go to the next program line, which is this one. Obviously, we'll hold the screen. Then it will evaluate. Do you have 5? Yeah. So this statement is false. You're out of the program. So notice I didn't need a system pause right before return 0, since I'm using it within the loop itself. So I hope you've learned a lot from this on how to combine switch statements with, or what we call conditional programming or conditional statements with iterative, with a do-while loop example. Could I have used if statements instead of a switch case? Answer is absolutely. You could have used nested if statements, serial if statements. The choice is yours and how you see it fit. A lot of it will be based on performance and the environment in which your program is going to run and compatibility with other programs, especially if you need variables out of this to use somewhere else. So at this stage, I'm concluding the looping section of our lessons. The next time around, we're going to learn about functions. And that's going to make our life a lot more interesting. I wouldn't say complicated, but actually better in terms of handling programs that require lots of lines of code. As you can see here, it's getting heavy. Within main, I have a lot of instructions. Now, let's suppose I was asked to go ahead and upgrade this calculator to include many other functions and subfunctions, which means other than your addition, subtraction, and sine, cosine, I want to do some other extra things, which means that will increase the size of this menu. Not only that, the list within the case will also increase. You will have a lot of contingencies. You're going to need a lot of different libraries here to support, especially the CMath library. You're going to need a whole bunch of things that if you try to cram them all in main, like we've been doing so far, could create an issue. Could create an issue in terms of readability, in terms of being able to, right from the start, understand what your intent was with the code, how to fix it in case there are issues. So those are extremely important in a production environment. So we want to be able to fix problems, break down ideas, corner them so we can actually have control over them. So procedural programming is our next step. And I hope to see you then for the next set of lessons that will include functions.